All right. Hello, hello. Welcome to a Dataiku live show and tell. Today it's with Dataiku and NVIDIA around how we're advancing healthcare with our two technologies. I'm Kelsey McCloche. I'm the Global Head of AI Solutions for Healthcare and Life Sciences at Dataiku. I'm joined with Shashank. If you want to give a quick intro, Shashank.
Hey everyone, Shashank. I'm a partner essay with Dataiku. Also joined by Brett from NVIDIA. Brett?
Yeah, hey everybody. I'm Brad Generu, Global Lead for Healthcare Alliances here at NVIDIA, covering developer relations in digital health and medical imaging.
Great. Well, let's jump right in. We got a packed agenda for the day. We are going to do a quick intro of some of the topics that we're going to cover today and hopefully get through. Throughout this, you'll notice there's a chat functionality or a question functionality. Please ask questions as we go along, both as we go through kind of an intro, what's that state of AI in healthcare as we see it here at Dataiku, and what our partnership with NVIDIA looks like. And then we hear from Brad around how he's unlocking digital health and medical imaging workflows with the latest and greatest from NVIDIA. We'll have some hands-on demonstrations from Shashank next, really about what that integration looks like, and then some specific specialized use cases around medical imaging using Monai with Dataiku, as well as no-code chatbots with using our LLM mesh and the NVIDIA NIM for large language models integration that we have. Quick look at where we see that state of AI. This is a survey that we did last year. And if you've heard, and actually if you were at NVIDIA GTC, you might have heard many of the NVIDIA leaders as well as ourselves say that healthcare is perhaps in the next 5 years going to be the greatest technology industry there is. But it's not just ambition or intention, it's already execution. There's already use cases developed across the entire value chain. Most notably in research and development and operations. But on the healthcare side, particularly as we think of getting into customer engagement or patient engagement and patient healthcare outcomes, there's really a lot of exciting opportunities. And this is tied with the intention of not just analytics and predictive analytics and AI, but also this rise and the intention of the use of generative AI. Perhaps some of the greatest use cases are going to be unlocked to improve patient outcomes in healthcare. Why is this the greatest technology future for us? Data is the fuel that is the fire that's building this fire around technology transformations that we're experiencing. There is more healthcare related data than any other type of data in the world, and it's growing at a faster pace than any other type of data. Millions upon millions of pathology images are getting digitized daily. Medical imaging is a big source of that, which is one of the topics we're going to cover today quite a bit. But it's more than that too. It's vast amounts of unstructured and structured data that's just growing faster than any other industry. And it's driving the necessity now, not just the option of new ways to handle that data, composable data frameworks. Of course, the real impact is going to be seen by the ability to implement multimodal models that take all aspects of care, genomic data, structured data, medical history, imaging data, longitudinal patient data, and make better healthcare decisions with them. And not just predictive, but even moving into that true prescriptive analytics or AI as well, where we can actually see causality between different signals in the data and how that can change the treatment options that we make available to patients. Generative, of course, is a big part of that as well. So this idea of union of between predictive analytics or even descriptive analytics, predictive AI, and now generative AI in order to see these transformations actually impact your business. For those that are joining that know and love NVIDIA very well, you're now going to learn and know Dataiku and why you should love it as well. Dataiku is a data science orchestration platform where we can connect to any of those diverse data sets, unstructured or others, coming from those different systems, as well as optimize and leverage the deep investments that most organizations are starting to make in their technology and IT infrastructure. That's optimizing the compute layer, especially accelerated compute like what we can do with NVIDIA. But also that ability to accelerate, democratize, and govern foundational models or any models that you want to put into production. And so if you look at how our partnership with NVIDIA, for example, can translate into use cases or into the diversity of applications, say at a biopharmaceutical organization, we can see how with our platform, you can surface up and accelerate and democratize the use of the specialized libraries in BioNeMo for AI-discovered, AI-designed molecules that your computational scientists, your chemists, or your biologists are working with in silico trials. You can go further with detecting and being dynamic around early efficacy in clinical trials for oncology by using MONAI and the medical image processing abilities there. You can even just think of as that vast amount of data sets become almost unmanageable, turning even traditional machine learning applications to accelerated compute foundations. And of course, it goes full circle into how we deliver patient care, where we can enhance the diagnostics and disease detections, again, with tools like MONAI that have been integrated into Dataiku. That was a very quick overview. We want to get into the meat and the fun of this session. So I will turn it over to Shashank for, Brad next, because he's going to share with us the very latest and greatest and things that we're working heavily right now to integrate as they come out from NVIDIA as they go further and further in their enterprise AI tech stack.
Awesome. Thank you so much, Kelsey. I'm super excited. So let me share my screen here. 1 second here. Okay, there. Can you see my screen? Perfect. So thank you so much, everyone. So again, Brad Generu, Global Lead for Healthcare Alliances. I'm going to step through a little bit of what NVIDIA is doing in healthcare and how we're helping to power some of the amazing workflows that Dataiku can do. So let's jump right into it. So NVIDIA's been involved in healthcare for, I'd say, more than 20 years. If you ever had a CT or MRI, those modalities are GPU powered. We're using GPUs to help us see things in medical images, to help us discover new drugs, new proteins, new molecules, to help us understand the human and animal genomes, and really to help in this next wave of digital health to be able to understand and use reasoning against our healthcare data, against healthcare journals, against research data, and all across the board. There are a number of different frameworks that NVIDIA has, across the board, built on top of the infrastructure, on top of the GPU. And if you're interested in kind of looking at some of them, double-clicking on things like MONAI, the Medical Open Network for AI, with Holoscan, our medical instrument platform, with Isaac that we use for robots, Parabricks for genomics, NeMo for language processing, and BioNeMo for understanding the language of proteins and molecules. Very, very much involved on the ground floor and help powering innovation all around the world. NVIDIA also provides the software layers I talked about with AI Enterprise, combining the power of foundational models with SDK frameworks, API frameworks that we can integrate inside of platforms like Dataiku to supercharge them with new functionalities and to be able to accelerate the work that our stakeholders are doing, whether that's researchers, developers, and really anyone in between. And really powering all the different types of workflows that we see in this space. My background comes from medical imaging, so I'll take a double click on one of our frameworks called MONAI and just kind of step through what it does and what the, how we use it in the course of creating healthcare models and ultimately powering clinical trials workflows as well as clinical workflows themselves. So MONAI is the Medical Open Network for AI. It is built on top of PyTorch, and it's a framework that we use to build medical imaging models and enterprise imaging models. It can be used for, things like CTs and MRIs, but also ultrasound, but also whole slide pathology and surgical videos. It takes what we learn from libraries that go across many different domains, like we see, for example, in automotive, being able to use computer vision to see a person walking across the road, and use that to be able to detect someone who's having a stroke or a brain bleed or has a nodule in their lung. And Monai's really provides that last mile extensions so that we can use medical images, because it takes more to look at imaging more than pixels. CTs, for examples, is really just a rendering in pixels of what is radiation energy flowing through the body and hitting a film plate behind the patient. Monai is our framework that is highly customizable, uh, enabling researchers to drag and drop and connect different components into their pipelines. And this is why I'm so excited with what Shashank is going to show us in a few minutes around really that composability of our pipelines and workflows that we need to do in this space. Monai allows you to take different components and connect them. It's highly reproducible, meaning that if we do research at one institution and bring it to another institution, if we use the same data, we should get the same result. And having that reproducibility is so important in the healthcare space. The framework is super easy to get started with things like Jupyter Notebooks. It comes pre-accelerated and optimized to run on top of GPUs and the architecture, beneath it. We offer foundational models like Vista 3D that allows us to do 3D segmentation in almost real time. And I'll give a demo of that in just a second. And Monai also has a ton of models to really get started. There's models in our model zoo for CTs, for MRIs, for we've seen ones for whole slide pathology. There's ones for mammography as well. So really all across the board. Used around the world, co-founded back in 2019 by both academia and industry. And to date, we've hit more than 2 million downloads. It continues to win challenge after challenge in this space at Mackay and others. In Mackay 2023, it took first place across 4 different competitions alone. It's used in more than 1,000 papers referenced, used in more than 1,800 projects, and I talked about the impact with the Model Zoo, 25 and growing. To make this experience even faster, to take what is an SDK and transform it into an API. This is where we have NVIDIA Inference Microservices, or NIMs. And this is across the board announced at NVIDIA GTC back in March to really simplify and expand the ability to integrate generative AI solutions at scale inside of your applications across many, many different industries, including that of healthcare. And we see ones for drug discovery, we see ones for imaging, we see ones for genomics, and much, much more. So I'm going to give you a very short demonstration of this in action. You in the audience can absolutely do this exact same thing with me right now if you like. What we're going to do is we're going to do 3 of the 4 steps here. I'm going to show you 3 NIMs. One is generating text using Llama 3. We're going to generate a drug molecule using MolMIM, and we're going to generate a segmentation using Vista 3D. So let me jump over into my browser. So as I mentioned, so here we go. Let me just make that full screen. All right. So if you go to, before I go full screen, build.nvidia.com. So I'll make that full screen now. This is the interface to experience NIMs and how you could actually call upon them inside of your applications. So as I mentioned, we've got foundation models for reasoning, for visual design, for healthcare, for different industries as well. But imagine, here's my use case. Imagine I want to create a workflow for identifying liver cancer. I want to create a drug molecule that could potentially one day treat liver cancer. And I need to be able to take that to clinical trials and identify livers and liver lesions in my clinical trials patient studies. So really quickly, let's jump over to the reasoning side. I can go into Llama 3 as a foundational model NIM and ask it, for example, what are the steps to treating liver cancer, right? So I can ask it any types of questions. And you can see here on the right the API call that it's going to make with some sample code, actually. So this is a 3-line API call. And you see that I get a response back almost immediately with steps of what I would do. I'm going to diagnose my patient. I'm going to provide treatment options, including chemotherapy, but also radiotherapy, also surgery, and many other details around the treatment of my patient. So fantastic. So we could use chemotherapy. So let's look at drug molecules. So let me go back now to our directory here. Under healthcare, there is a NIM called MolMIM. This allows us to generate from an existing drug molecule new drug molecules that are improved on specific characteristics. And in my list of samples here, I have one for, you can see ibuprofen, for example, but floxuridine is a drug that treats liver cancer. I could take that molecule, run this through, and get back a number of different molecules that use those properties and enhance some characteristics of it. So in this case, we are optimizing on QED as my molecule that I've created. And you can see it's made a number of different molecules that I could then potentially explore. So imagine now I've got a drug. I want to take it out to clinical trials. I'm now getting in imaging studies and including the people's livers essentially with CT exams. So I'm going to go back now to healthcare super fast to medical imaging and open the full model. Here, 1 second here. And what you'll see here is I have a CT study, right? So full CT study, abdominal CT. I can look at it in different views, coronal and sagittal views. If I like, I can use my mouse wheel to kind of wheel through the stack. But I'm looking for livers and I want to automatically segment them for my workflow for ingestion. I could just apply a class label for look for liver and run this model. It takes about 5 or 6 seconds. This is up in the cloud. And when I get a response back, I now should, if I scroll through the image, I've identified the liver in my CT study. So now I can do things like calculate volume. I can look for lesions. I could do, all the things that I need as part of my clinical trials, but I don't need to have, a lot of manual intervention. I can automate some of the pipeline for actually doing this. So you can see here the different views of the body where the liver is located, and the same thing here on the sagittal view as well. So that's NIMS, a really short dive into it. There's so much more that you could do in this space. And I'm so excited about the integration of NIMS as well as Monai inside of the Dataiku platform. So let me turn it over to Shashank to walk us through some of that.
Thanks, Brad. And this Vista 3D demo is so amazing to see what Gen AI can do nowadays. Let me share my screen. So I just have 3 slides and then I'll go jump into the demo. So quick overview of what Dataiku, just following up what Kelsey mentioned. Dataiku is analytics workbench platform. It's a platform for developers to build their data science projects. It provides capability for the whole end-to-end data science project lifecycle, starting from accessing your data to all the way to deploying it in your production. The tool caters to all different personas. So you will see in the demo, we have a lot of visual capabilities for no code, low code capabilities, as well as we have full coder interface. Like you can use Python or Jupyter Notebook. Coders can even choose their own choice of their IDE like VS Code to build application within the platform. To an organization, it helps create a self-serve analytics environment. It creates a collaborative environment for coders and business SMEs to work together at one platform. The whole application comes with also some central services to make sure that everything that you build has proper governance capabilities enabled, version management, auditability, and promotes the reusability of already built-in components. Since we're talking about NIMS today, it's very important to understand what Dataiku LLM Mesh offering is. It's in the same principle as before our MLOps are, is to create an environment where a broader workforce can build applications using built-in capabilities, and also to make sure that everything is built in a fully governed manner with proper security controls, cost reporting, audit trailing available within the application. So if you see on the left-hand side in the architecture, we provide you a Kubernetes interface Kubernetes cluster, which comes with NVIDIA GPUs enabled. So you can use to host the self-hosted LLMs coming from Hugging Face or Meta. You also have connectivity to all the hosted LLM providers to choose from. And then in the self-hosted LLM, you will see we'll also getting the NIMs now available. It's about to get released in coming releases, and I'll show you the beta version of it. I have access to that. And then you can also connect to the vector stores, choice of your own vector store, whether it's the cloud-based Pinecone or your local embedding vector stores. The last slide is on the NVIDIA integration. So what you're seeing, the green box is the whole Dataiku interface, providing all those capabilities showcased in the smaller squares. On the bottom, on the left-hand side, this is where you get a built-in environment for your infrastructure with GPU access. So you can connect to your NVIDIA DGX cluster, cloud or on-prem, or you can take advantage of NVIDIA GPUs from any of the Kubernetes offering from clouds like Amazon EKS, Microsoft AKS, or Google Kubernetes Engine. So that covers to make sure that as a developer, you don't need to worry about the infrastructure. We have built-in CUDA environments for you. So you can just have a GPU access. As long as you have a GPU node available in your Kubernetes node, you can take advantage of for any kind of processing, starting from your data prep to all the way to fine-tuning your large language model. Now on the right-hand side on the below box, we showcase a software offerings from NVIDIA. So once you have the infrastructure, as a coder, you can take advantage of any models like Vista 3D model that Brad just showed, or Monai's. Any software offerings you can take advantage with a coder interface. The integrations that you're showing in this box is to showcase what are we have with our visual interfaces. So also like you can use those services in a no-code, low-code fashion. So right now you can run your data prep like Spark codes on GPU using Rapid Spark in Dataiku. You can take advantage of Rapids ML, which are open source algorithms optimized to run on GPU. So it runs that fast, it will reduce the cost of overall running the program. And then we have Mona integration, which we showcase, and also a recent integration with NIM LLM models, the chat models. So it showcase a chat bot of market intelligence using Llama 3 models, as well as NVIDIA embedding QA models to generate embeddings. So that I switch it to the demo. The first demo we have is we are using NIH chest X-ray data, and we showcase how you can use that data to use a Mona 2D image classification model and fine tune it on this data set and generate a new model out of it. Now, before we get into the model, this is what you're seeing is a home screen of Dataiku. It's a web, you can access this through web browser. It's run on a Linux machine. Quick items on the integrations. So in the clusters, this is where you set up your DGX cluster or our Kubernetes cluster with a GPU node. So you attach to it. So first thing is cluster. Second thing we need, you can configure your container configurations. So you can define is like which team, which groups you want to give access to GPUs, how many GPUs. So you can define like this is I have one default with no GPUs, and then I have one EKS GPU1 where I'm allowing one GPU access. And this is where I can use permissions to select which group can access what. And based on the access as a developer, I'll see these options in the drop-down while submitting my code. So that's the second layer. Third is where I'm going to set up the Mona environment. So in Dataiku, you can set up your code environments, Python or R, or import your already existing requirements file. So you can like here, I'm choosing Python 3.8. It comes with some default packages. Here you can add additional packages. So I'm adding Mona. That makes me one of the downloader from that 2 million list that Brad showed. And then MLflow, and then any additional packages that you need, you can add it here. In the container execution, you can say, okay, I want this code environment to work with my GPU container. So now this concludes all the setup. So your GPU and the CUDA environments come pre-set up. You can just set up your code environment as many as you want based on extra libraries that you need to run your code. And within the runtime edition, this is where you can also add CUDA. So if you do not have a CUDA available in your container, you can just directly use the support to have your infrastructure set up. This will overall reduces a lot of burden on developers to set their own infrastructure to start with, getting GPU access, setting CUDA environment, and get all those libraries. You can do that directly through this interface. Now let's go to the project. So this is the project we have. In Dataiku, every project has its home screen. So on the right-hand side, you can see the full revision history of the changes your team is making. It's like more project owner screen. You can see all the metadata associated to the project. And here you can set some description around this project. You can also start discussion around this project with your teammates. You don't need to wait for the Scrum call the next day. So let's get into the flow. So flow is your whiteboard where you're going to actually design your pipelines. You do all data prep, model training, model evaluation, all within the flow. Go first into the data prep zone. So all these blue squares is your data set. So we have the chest X-ray data files uploaded here and uncompressed in these folders. We also have a metadata available for this data set. So that also we have uploaded the CSV file in Dataiku. So you can see it provides an image index, like all these columns. You can define a sampling strategy to see how much data you want to see it in the screen. It does not actually fully upload the data unless you specifically ask for it. So you can define those sampling strategy, choose a number of records, and then you will use this screen to do your exploratory data analysis. So the first step is you want to identify what changes I'm required on this data or what kind of cleaning I need to do on this data. So I can quickly start analyzing these columns. So I want to make sure image index is unique. Looks like it's all a unique values. See the classification category, how it has been distributed. You can see I have 57% with no findings. I may or may not need this data. I can also see fields having multi-classification, like multiple values associated to it. I may want to flatten them out, convert it into one-to-one mapping. And then this is a patient follow-ups. We have patient IDs, age column, gender column, and some additional metadata associated to it. So this is to show how I can quickly analyze this data sets and I identify what changes I need to make. Once I identify that, if I click on the data set, on the right-hand side, you see we have visual recipes, code recipes. So all your yellow recipes are the one which are visual. It like provide you and give you a no-code, low-code interface where you can just drag and drop processors and run it on your data set. If you want to further customize it, you can always use a Python or R interface to do that. Even also PySpark and Spark R2. And then we also have some LLM powered recipes that we'll cover in the second demo. So here in this data sets, I identified some changes which I want to apply. So let me turn it off, the changes we have already applied here. So when I click on add a new step, you see we have around hundreds of processors available for you, from filtering data to string functions, mathematical function, handling geographical data, as well as writing like a small Python function if you want to customize other code. So you can choose from these functions. So like if you see, for first thing, what we're doing is just removing the columns that we do not need. And as soon as we enable it, you see that change happen. It does not apply to the full data set. It is just giving you a preview of the changes you are making. It is very helpful before you push all the code to run it on a full data set. You can run it on the sample. Once you're satisfied, then you can click on run to push it back to on your database or on a Spark cluster, wherever you are running. So we remove the columns, we rename some of these columns, like removing spaces from that. And then we want to split this column by labels. So we split it. So it will generate an array of these columns. Now, the other thing, I want to create a flag where I tag the patient IDs, which has multiple disease identified in their X-rays. So I created a count, small formula, Excel-like formula, where I'm calculating the array length. And then I want to flatten the array for my further data analysis. So I did, and I flattened the array, and then it increases my data size by 12,164 rows. Now, once I'm satisfied, I can choose the engine where I want to run this. So based on where your data store is, it will recommend you the engine. So right now you can run it locally on DSS or on your Spark cluster. Your Spark can be any Kubernetes cluster, which I showed earlier. If it is in a database or in a Hadoop environment, you will see other options pop up. So you can push the compute back where the data is, and you do not need to transfer data within the Dataiku environment. Now with that, when I choose Spark, this is where I can choose Spark configuration. So you can run it on CPU, or you have pre-built GPU environment. So it will directly run using Rapids on GPU. So once we run it, we have this updated data set. Now I can see that those changes has been applied to the full data set. As you can see, the record count has been increased, as was mentioned there. Again, I can choose the sampling. Now, my next step is I want to make sure I work with my business SME and demonstrate what the data looks like before I call it that it is ready for training. So I can start building charts on that. You can see where I have 10 to, I think there's 20 options of pre-built in chart, and you have all the column lists that you can apply. You can apply filters. You can even create new columns for chart using this aggregation method, and then further few more options for you to further customize it. So if you see this one chart where we are creating a distribution of disease by gender, we have the legend available here, and then you have blue icons with the male count of records on the specific disease and the female one. Similarly, we can see the age distribution across this and data set. You can see from male, it's mostly going from 50 to 70. For female, it's going from 40 to 60. And then if I wanted to see, okay, for specific one disease, what is the correlated disease which is showing most of the time? So what I did, I specifically go to a cardiomegaly and put a filter. And then I also put a filter to have at least two classifications. So I don't want to include those which just have the cardiomegaly for this dashboard. And similar to that, I can create multiple of them, publish it on a dashboard. So you get a dashboard view. And this is something you can share with business SME, or you can use that to work out if this data looks good, if there is any further changes need to be made. As you can see, we have also created the scan key view where you can see how with a patient cycle going from first follow-up to the third follow-up, you see the no findings is reducing and you have more and more diseases identified over follow-ups. So you can create that to fully explore your data and then take control, define business rules accordingly on that. Now, once you're able to do that, now you can also define you can also create statistics dashboard. You have multiple options like bivariative, univariative analysis, multivariative. So pre-built dashboards that you can create. Then you can also create metrics. So this option is available on every data set, every blue structure that you see. So you can create metrics. So you always want to monitor the patient age, mean, average, max. You want to make sure that the gender always contain the gender values and nothing else. So you can create that metric. You can create some custom metrics also using Python. So you can use some pre-built metrics, and you can also create using Python more. And then you can also apply checks. So you want to make sure that your data quality checks runs every single time when we are preparing this data. So here example, I define a check on gender validity. I want to make sure we should not have more than 10 records, which comes under that. And then you can use these checks and metrics in your actual orchestrated flow, whether to continue with training a model or to stop if the data is not correct or throw a notification on that. So now I've done all the data analysis. I built all the dashboards that are required. I created metrics, created checks, and now my data is ready to join with the actual file data. So what I did here is on my filing, I use this list file recipe, and then it actually convert that into a tabular data, provides all the location. Here I may want to skip those zip files, don't need a size column, so I can remove that. So after doing everything, I joined these data sets on the image ID. So image ID is also the file name, so it's able to join that, and created my final data set. Now I'm ready to train this data set on a pre-trained model. So now you have multiple options. So once you get into final data sets, I use a split recipe to get into train and eval data sets. And then I go to lab, I have image classification, where I can do visual analysis on this data. So once you click on that, it will bring you to this screen. You can see all the X-ray images. It's preload that. You can see it automatically identifies the column, which is labels, which has to be identified, like has to be predicted. And then you have the path, the folder which contains the data set. and then you have the list of classes. And then you can pre-configure using visual ML. It automatically comes pre-populated, but you can pre-configure it like how you want to split your test and train data set, which algorithms you want to use. It provides some like open source image classification algorithms, and then other configurations that you can apply on that. And at the end, you can also choose whether you want to run it on GPU or not, how many GPUs you want this model training to use. You need to make sure you are attaching to a container which have access to the GPUs, and definitely your code environment. Now that's the one option. The other option is, oh, now I wanted to use Mona because Mona have pre-trained models specifically for medical imaging. So they will have more accuracy when it comes to medical images. So now with that, you have two options. We can either use a Python recipe. So here we are using a Python recipe. We make sure that we tag it to the code environment that we built from Mona, and then you can select a container, a GPU container that you wanted to run on. Now in the code, this is a default view, but here you can see I can edit in a Jupyter notebook or in a Visual Studio or any choice of your IDE. I'm importing all the Mona packages here, and then I use this code. These are all my variables to train my model. I'm also using MLflow because Dataiku has an integration with MLflow. It will give you access to some of the visual features within the application that you can take advantage of. Now, once I train the model, because I use MLflow, it actually outputs two things. One is your diamond icon, which is your model. Another is the whole artifact, the whole model file. So here you can see I have all the runs recorded here, and under that data folder, I have this my PyTorch model available for you to run. If I go to this MLflow view, here I can see all my model version has been recorded. History has been maintained. If you go and click on this, it goes to the whole model summary. You can also export this model. Apart from that, all the metrics that you recorded using MLflow will be available for you with every model version and every run. You can keep the whole experiment tracking history maintained within Dataiku using that. So that's the one option. The other option is you can use the plugin that we have built. This is specifically for 2D image classification. You can use that plugin. Organizations and users can build even their own plugin. The only thing is we just use this code and make those variable as a configurable parameter, and then use it as a plugin. So it increases the usage with a broader workforce. So you can configure all those things which are variable, and then again provide the container where you have GPU access here, and then you can, and it also exports a model file. So that's multiple options for you, and this will. So now you have the PyTorch model, MLflow model. Now to take it to production, you can launch this model as an API, or there are certain MLOps feature in Dataiku which you can use to orchestrate this pipeline and run this model on a batch data set to take it to the production. So today, as part of the MLOps, we only covered how you develop end-to-end pipeline, but there's a lot more to cover on post that, which helps you take this model from dev to production, have the proper governance rule, have those alerts identified, and apply on this model. So that we switch to our second demo, which is on the NIMS. So our second demo talks about a chatbot that we're going to build using for market intelligence teams. So it's the same project screen again. The only thing that I want to additionally add in the administration, now within the connections, you have this LLM mesh section under which you see all these providers available. We'll soon will have an NVIDIA NIM connection also, but even today you can connect through the custom LLM option. Under that we have a plugin NVIDIA NIM LLM. So I already have it set up. Let me quickly open that. Now I also go to the same build.nvidia.com, and then what I need here is the endpoint from this. You can generate your API key directly from here, and then the model name. Those are the two things you need to configure that in Dataiku. So we go here and then we create an ID, provided it's a chat completion. This is where my token is stored, API keys, endpoint URL, model key, and then some default configurations that is applied on every connection. Similarly, I'm also using an NIM embed QA model. This is for generating embeddings. This is also coming from NVIDIA Cloud. Same process, model key, endpoint URL, and the key where your token is stored. Now, with every LLM mesh, LLM connection that you make, you can define who can access this connection, whether you want to enable caching or not. If you enable caching, it will save you cost, but will always respond the same response if you use the same question again. What level of auditability you want to enable it. And then you have a couple of security guardrail hooks available for you. Like you can choose some data set which contains some forbidden terms like customer name or some GXP level information that you want to hide. Toxicity detection, PII detection. You can apply all these on every LLM connection in Dataiku. So what happens? Every request and response first has to go through these hooks before it hits the model configured. Now we go back to the demo. So here what we are doing, we are downloading articles from Fierce Pharma, Fierce Biotech, Fierce Healthcare, and then we are generating embeddings on this data set. So we need to make sure that these large language models has been trained up to a certain time. Now you can use a RAG architecture to keep feeding the latest information on the same large language model and generate responses based on a recent updated information. So you created this flow where we are downloading these articles, then we're using a stack recipes to create it like a one single data set. So here you can see we have the source, article title, when it is created, changed, we have the full body of that, and then additional information associated to that. Now for me to convert this embeddings, again, I have these visual recipes available. You always have an option to go and choose Python if you want to further customize it. So we have these pink recipes available. You can see we have some NLP specific tasks that now are LLM powered, like text summarization, text classification. We have a prompt recipes and the embed recipes. For embeddings, you're going to use the embed recipes. So here you can define the column for which you want to generate embeddings. And then you can add any number of columns at a metadata. Now this metadata can be used to filter your search in your vector store, as well as use these metadata to display the sources whenever the response is generated by the chatbot. So you provide this metadata and then some additional settings like how I want to split it, how many records I want to process, what should be the chunk size, overlap, and then I can choose the embedding models. So I have access to embedding ADA and then NIM embed QA model, which I configured initially. Then you can also choose your vector store type, Pinecone, like we have some of them by default available for you. You can also use Pinecone Cloud within Dataiku. And then you have pre-built code environment that will work with that. Now, once you generate the embeddings, now you can take advantage of things like prompt studios in Dataiku to test how your model is behaving. You can directly hit the NIM Llama model, which is available through NIM, or through this augmented model through prompt engineering and generate the responses. Now, the last thing what I have to build a chatbot, we use Dataiku web app feature. So in Dataiku, you can create code web apps using JavaScript, Shiny, Dash, Bokeh, or you can use visual web apps. These are like pre-built web apps for you, which you can just customize using the configuration and directly use it. One of them is our answers chatbot. If I go to this edit screen, so this is the screen of the home screen of the chatbot view. And then this is where you can fully customize and configure this. You can define where you want to log the data set, how you want to capture the feedback, what LLM model you want to use. Here you see we are using Llama 3, the same model that Brett showed in her demo. And then we have the knowledge bank. You can define the name, fully customize your, like, what is the system message for the LLM that you want to give? What is the prompt you want to give to your retrieval vector store to retrieve embeddings from that? And then what metadata you want to provide users to filter the information on. So all the information you can fully customize and configure, and this is like ready to go chatbot for you for your use case, applied either to your embeddings or directly to a large language model. You can also update the whole end user configuration, like what is the sample questions you want to put, what is the title of the chatbot. So with that, I'll hand it over to Kelsey to showcase the end user experience of how this chatbot can help them.
Thanks, Shashank. Yeah, I hope you enjoyed both of those examples. You know, one of the things on that first one, of course, we did diverge a little bit from our sticking to liver cancer with a little chest X-ray fun. But, you know, one of the things I liked about the EDA and going through some of the very basic analyses things is seeing, for example, that Sankey diagram where you can see the different disease or condition classifications from those images changing quite significantly across different follow-up visits for the different patients that we had. Maybe even a data quality issue as you think of that data going in and feeding into something that's going to make a clinical diagnosis decision-making tool. Let me go ahead now and share back to that same. So the beauty of Dataiku again is I can, let me just find my window. I can now go back straight to that web application that Shashank has set up for me. And he's even been so nice to give me a sample question that I can ask. Now, here within that, you see, as we saw, the real value of this is that we've been able to take that general purpose LLM that can answer questions generically and curate it and actually specifically use the knowledge that I want in order to understand things. Now, if you look, I tried this out yesterday a little bit. If I turn off this knowledge base, this is the request I gave in terms of what are those clinical steps to treating liver cancer, you can kind of see the same type of answer that was brought back to Brad. But now I'm really interested in more. I want to go through and use that curated knowledge bank based on all of the latest advancements, news articles from fierce biotech, pharma, healthcare. Perhaps I want to really be specific where I could specify the types of filters where I want that curated information to be coming back from in my RAG chatbot. And so I can ask this question now to say, hey, what are the steps to treating liver cancer? But what are the recent or new developments that are coming that might be changing what my standard of care should look like for liver cancer? Are there new therapies that we could add into our clinical workflows? Are there new therapies that are going to change what that standard of care looks like? And so we can start to see some of the recent advancements in terms of new therapies that have been coming to the market, or different updates around new indications for some of these things. So right now, quickly, you can see a couple things that's coming out of this is that you can already see that we're curating this specifically to sources where this information is coming from. And the prompts that we set up asked it to be very specific to that. Don't try to go outside that. Find what I want to know from the curated knowledge base that I gave it. And so we can see all of these different advancements. One here, you can then look down and see all of the citations coming from this knowledge base that we've been able to build. And I can continue with that. So this one, for example, trying to connect back, I know was actually originally developed for small cell lung cancer. So we can ask, how was this really developed? And what was the timeline of the development of infancy? And see when it really started being something that could apply to liver cancer or hepatocellular injury. And so now we're starting to get an even further contextualized information about the development of that therapy and how we might want to be considering it given the upcoming or new regulatory decisions made about it, of how we might want to put that into our own standard of care. Now, even more impactful than just here, which we're using a curated, still public news source to find out information about new markets or new therapies that might help a patient. If I'm a healthcare or a hospital system or a health services system where I am considering how could this new therapy help my current standard of care or my current clinical practices, I could actually build a more impactful knowledge base based on my own clinical workflows, based on my own standard of care practices, or even summarize the patient discharge notes or information, the vast amount that we have on patient data, in order to better tailor, should I be adopting a new therapy that's coming to the market into my standard of care practice? And so really that's kind of the power of this ease of being able to build these chatbots, but tie it to those curated knowledge base through something like RAG. And the beauty, of course, is when you use something like an NVIDIA NIM container, that can be completely private, that can be secure. So you can actually even allow an organization to embed and use large language models, open source large language models, where that container environment has all of the AI infrastructure needed in order for you to actually embed that into business securely and under the constraints of sensitive patient care data. With that, I will stop sharing my screen real quick. And we have about 10 minutes for questions. I think I see one already in the chat. A couple things that I'll just cover before. We did have a question around the subscription model with NIMS and Dataiku. So Dataiku as that orchestration layer, as a platform, all of that comes with part of the licensing of Dataiku. The capability, of course, we don't provide the NIM, but if you've made that investment with NVIDIA technology, then that's where you get the acceleration by tying it into the Dataiku platform. There's not an additional subscription model for that. In terms of our LLM mesh, we do have an advanced LLM mesh set of capabilities that is an additional license on top that offers a lot of cost guard monitoring, enhanced governance, et cetera. Another question that I saw come through was around this recording, and that will become on-demand available. So happy to do that, and I believe we will also share the slides, but I'll let Brad comment about that for his.
Yeah, I'd be happy to share the slides. Yeah, no worries.
Great. And then I think we see a question in the chat. Can the healthcare have the program bots for all illnesses related AI integrations are the cause for such diseases? I'm not exactly sure what that question might mean. Any interpretations of that one, guys?
Yeah, yeah, go ahead, Brad.
Okay, all right. Yeah, rock, paper, scissors. What I would say is, developing these frameworks like Monai, like what we see across the world, and then powered and harnessed by platforms like Dataiku, really allow us to start to create these models at scale. So, for example, if I want to have a model for lung cancer, for liver cancer, for brain cancer, for pneumonia, for stroke, for brain bleeds, for fractures, and kind of everything that we want to be able to do, we need to have an accelerated stacked framework for us to be able to run this. And if you think about all of the effort that it takes to just create one model for one disease, or even one stage of one disease, and then we want to expand that to in medical imaging, there's approximately 14,000 things diseases and conditions that we could see in medical images, and we need to have that framework that we can build on top of, so that at the end of this journey, this AI journey, we'll be able to have that network of networks of AI inferences that can give us the insights across all the different conditions and diseases that we might have. So I'd say that's definitely going to be the end state for a lot of this, that we're able to get these insights to help us and help our caregivers. But I'd say it's still a long journey before we get there.
Yeah, and I'm not a healthcare expert here, but I think on a technology level, the things which I see is changing in Gen AI is, in parallel to large language models, now you will start seeing more small language models, which are trained for a very specific things that you want to achieve. So you will have these small language models coming up in healthcare industry also, very specific to these use cases, can do like 4 or 5 tasks, but they will have a very higher accuracy of doing that. So those becomes like a bots in your machines and everything, to treat, easy to install, do not need large memory, but can only do specific things that you're looking for.
Mm-hmm.
Yeah, well, one more comment that I'd make is that in the world of APIs and SDKs, but in particular APIs, it really comes down to how fast can you get things going. In the world of creating like APIs for like the Twitters and the Facebooks, there's a metric that we use called the 555 rule, which is 5 seconds to find the documentation, 5 minutes to proof of concept, 5 hours to a kind of an end-to-end integration. And we need to see that same sort of mentality when we're creating AI models in this space, that we're able to create that at the speed of light. And it's really only through these frameworks that make it scalable, that make it repeatable, that make it enterprise grade, that really makes this within reach of our data scientists, our developers.
Yeah, and I can agree with that too. I think there's always been a lot of hesitancy, despite the opportunity to tackle some of, especially clinical care decision making with AI. But the speed, not only the speed with which we can build these things, but also test them, try them, and then put a governance layer around them. I think a lot of the new regulatory impacts that are coming out around AI as a medical device, for example, and how you embed it into patient care models. These are actually good things in many ways because it helps us see a viable path to acceptance. So we have both acceleration and we have both regulations that ideally will keep us on that path to acceptance, right? And transparency. So patient care decisions, of course, if that's being made or impacted by artificial intelligence in any way, there's a lot of transparency needs that are happening now. And one of the things we've liked about our partnership with NVIDIA is they're providing all of these amazing tools of acceleration, and we provide the enterprise scale and governance that allows you to really do some things with that and put it into the hands of not just your niche programmers or your niche bioinformaticians or your niche medical informaticists, but to those clinicians, to those healthcare decision makers. So it's a really powerful component. I also do love, I saw in the chat, I love the 555 analogy too. Thank you, Brad, for sharing that. I'm going to steal that. I'll cite you, of course. And I think what was the last question? I think that might have been all the questions we see. I did another one, a follow-up around, can we actually with AI trigger where the disease rooted from? That's an interesting question.
I've certainly seen so the database that I use is called GAMUTS, GAMUTS.net, and that connects what we see in medical images with the possible causes. And so I think it's a combination of both what we understand from, using reasoning engines like Llama to parse the literature, but also parse the knowledge that we've gleaned over the last, in radiology, more than 100 years, and use that as part of enhancing our understanding of both, why these diseases are there and how do they progress and how do we help our patients and help develop the therapies that will ultimately make a difference in their lives.
My own background, I come more from the genomics biology side too. Like I think of it even as how you actually see it in our biology and some of the advancements in terms of new technologies at single cell sequencing or spatial transcriptomics, where you can actually classify and see the literal cellular deviations that are happening at the beginning of disease within the body is magnificent advancements that are going to allow us to understand, characterize disease so much more quickly, and then design or even AI design molecules that are tailored to that. So it's a really exciting time from both angles of understanding the spread and the understanding of that, but also the body systems and the biology that's really at that root cause of disease. Of course, I think there's still a long way to go. I don't think we have like a true large biology model that's performant quite yet, but I know a lot of people are working at it.
Yep.
Yeah, I don't think we have any more questions. Just quick takeaways. So NIMS, even if you do not have a license, you can start using it today. Go to build.nvidia.com. You get 2,000 credits. And you can start playing around with it. If you want to see any specific model in your Dataiku, do reach out to your customer success team, or you can directly reach out to us. We are looking for feedback. What's something that you're using today, how we can simplify and make that process smoother for you. So thanks all for signing in.
Thank you.
Thanks, everybody.
Thanks, everyone. Bye.
Take care. Bye-bye.